night. Good afternoon, everybody. How was lunch? Good? Delicious? Now, the tough part for me is I get you right after lunch. And I'm going to be asking your first brain to do a lot more work than your second brain. And those of you that have ever squatted right after eating something, what happens when you ask your first brain to do, and your muscles to do more work than your second brain, your gut, your food will exit your stomach, right? Because it's no longer concerned with digesting, it's concerned with blood flow to the muscles and so on. So in that being said, got an extra, does everybody have their bands today? Oh, come on. Well, this isn't going to work, is it? Because I was going to have you wrap it around your forehead and hand it to the person behind you so that if you fall asleep, they can wake you up. Alternatively, I could open up a bottle and throw capsules at you. Not a good idea. Back when I was 14 making capsules for another company that's in the family, I got in trouble for doing just that. Turns out when you're 14 and you're running encapsulators, and you also have air hoses and stuff in the room, that an air hose and a capsule go really well together, and they can shoot out probably 20, 30 feet per second when you put them next to each other. Don't do it, but I did. It's not a good idea. And you can hit people quite a distance. People in packaging didn't know what was happening. Okay, we will get to these later. I'm going to try something slightly different. There is a lot of information. If you've cheated and gone ahead on my slides, you're going to see a lot of information. And much of that information is for your future reference, because even if I go over it today, you all know that it's really tough to have this all absorbed in a 1-hour period. And this talk is broken up into 2 sections, because we have detoxification as we all are experiencing it and have experienced it over the last little while, and we can go back in time as well as to the present and look at detoxification as I think we can all really get our brains around it. And then I've added this biological detoxification piece, which includes phage, that we'll get into in more detail. And you could classify phage in a number of ways. Today we'll kind of focus on this piece. But to take a step back, I want to say detoxification is something that I think is part of our innate world, right? It's part of history. It's part of the story. It's part of our story. And I think Mojan mentioned something over and over again, and that is, tap into what you are and who you are and what you want to become and your passions and your dreams. But in the process, be grateful for being here today. Be grateful for who you are. And that's an important point, and I know Nicole also emphasized it. This morning on the way to work, I was coming in early because we had the tour. Those of you that, we had the tour, so I was coming along, and I had to make a left off of one of our busy streets here in Ogden. And I can tell you that it's the first time I've seen this, but I was very grateful for having sight, because I'm sitting there at the light, and this young man, I would say maybe 20 years old, dressed up, he's had his suit and everything on, and he was blind. And we don't have a lot of really friendly roads for blind people, especially in the smaller parts of the town. So he's come up to the corner with his stick, and he's feeling around for a light, a signal. And I don't even think there was a signal, so all he had is red light, green light, right? And of course he doesn't see red light, green light, and there's no noises. And I wanted to get out of my car, but he figured it out pretty quickly. He found where he was on the sidewalk. He could feel the little tiny paint above the cement where the lines are, right? You could see he was swinging his thing, and he found the paint, found where he needed to go, and he ran because he didn't know whether traffic was coming or not. He literally ran across this 4-lane highway. And he made it across, but he veered. He was going so fast with his stick, and he ended up kind of heading into the other lane a little bit and had to hurry and kind of find his way back onto the other side. And when he got there, you could see he was, he was panting, and okay, another street crossed without getting hit. And I was extremely grateful that, well, one, it was amazing to see. I mean, good for him. And then he walked over to a bus stop. He found a bus stop nearby. And it was amazing to see, because I hadn't seen that in a long time. And I was grateful that I have my sight, my family has their sight, and crossing a street isn't a very, very, very stressful moment for me, right? Compared to him, you know. So I'm grateful that that happens. Now, we all have our own challenges and things that can create stress, and I think that's why detoxification, it's known by many other names, meditation, you know, however you want to play it, it's important to us. It's important to our soul. It's important to our heart. It's important to our physiology. It's important to our family. Those of us that are in relationships, how terrible is a toxic relationship? It's terrible at all levels, And we can stand up here and I'm going to give you a lot of science and I'm going to tell you why I'm so passionate about herbs and how herbs can affect you deep inside your cells, not just inside your tissue, but inside the cell. When we provide things, we are looking for the source of where this thing goes to help you. But if you back off of the microscope and get into a telescope where you're seeing the universe, the importance of detoxification is because of vitality, because of life. You can heal a cell, you can fix a mitochondria, you can help the endoplasmic reticulum and all these things that we want to do for ourselves and for the people you treat, your patients and your friends and family and so on. But the reason you're doing it is to give them a wonderful life, allow them to experience a wonderful life. And the opposite of that, the toxic side, is clearly not the path that creates happiness and thriving. And women's bodies know it even better than men's. You know, I think we can all agree, and it's no longer speculation, but we now know that when a woman's body is toxic, and if it gets toxic enough, they cannot reproduce. Why? I mean, you know, we can think of it biologically, but why would you not want to bring another life into that world? Because you're bringing a life into an environment that is extremely dangerous to that new life. And take humans out of there. This is true for all animals. This is true for microorganisms. If their internal structure is if they're damaged by toxins or they've been hit by electromagnetic radiation of some sort, or they will not reproduce. They don't necessarily go into active death, but they won't reproduce because they're toxic. They know that if they do, they've now perpetuated a toxic situation. So all life at all levels knows that's a terrible thing, right? There's a consciousness throughout, and that's a talk for another time. And we mentioned the other thing too. You guys are going to be getting, again, a lot of information, so I want your brains to be prepared. And our attitude towards this is amazing. I'm not going to spend any time on that. I'm going to get in the minutiae and the science and stuff. And I'm trying to get through that quickly. I'm prepping you right now because I'm going to move relatively quickly in order that we get to some clinical questions and some clinical troubleshooting at the end. Normally what happens in my talk, I go through my detail a little more slowly, and then we don't have time to get into the clinical applications. So I'm going to try it differently. Let's pray that I do that and I don't get sidetracked, okay? But just recently, speaking of the brain, to prep you for positive thinking, an article was released. People are getting really good at mapping the brain. The brain has been the biggest mystery on the planet. It's like the bottom of the ocean or even the middle of the ocean. We don't know what's going on there. We know stuff happens because whales go down to eat giant squid and they come up with scars all over them, but we've never seen these squid, right? We don't know how deep they go. And there's all this unknown about the brain, just like there is the middle part of the ocean. And we're getting better at it. And the most recent mapping is they took a whole bunch of people that live in a very negative, they call them whiners. They were from some vernacular that was slang, and there was some clinical vernacular. But needless to say, these are people that don't have a positive outlook on life. They take every event in their life and they associate it with a negative piece, right? And they've even classified them. Some do it for sympathy. Some do it because it's innately their behavior for whatever reason. And some do it to get other people on board with it, right? So for example, if you go to a rally and you're the guy in the back going, we hate blah, 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 you're creating that. You want followers. That your brain thrives on that condition. Well, it turns out that behavior, negative behavior, is now creating neurological maps that become ingrained in you, not unlike addiction. So these neurons are reforming, reassociating, And so the next time you have a negative thought, it happens more quickly. The next time you have it, now it's happening in milliseconds. And pretty soon your brain is now mapped for negative thinking. It's like curing an addiction at that point. You're going to have to remap your brain in order to get out of that terrible mindset that you're in. So it's not only important emotionally, as like Mojan was telling us earlier, you can change your brain through your thoughts. And that's going to be true everywhere. All right, let's get into this. So you with me? We have the bigger picture, why we want to do this. I'm going to give you a lot of details as why Systemic believes in herbs, believes in nutrition, and why the legacy all the way back to Doc is tapping into all these amazing things on the planet to help drive health into the cell. That's what you're going to learn, and then we'll get back into the clinical. All right, so like I said, there's on these slides, you're going to have a lot of detail regarding these subjects, but it is an innate issue to want to be free of toxins. It's not just you, it's all animal species, and a lot of other animals do it in different ways. We've watched monkeys do it, we've watched other birds, they do it in really amazing ways. I won't bore you with that, but it is exciting. So we know toxins come from a lot of sources. It's becoming more and more difficult to avoid them. There is now nowhere on the planet that we do not find plastic. At 29,300 feet, the bottom of the Mariana Trench, they find plastic. At the top of Mount Everest, we find plastic. There's nowhere to go that you will not find plastic, right? There's movements to start changing this behavior, but there's nowhere to go at this point. I think there's even garbage on the moon now. Yeah, so maybe Mars. Objectives. So we're going to talk about getting into the cell. I'm going to tell you a little bit about toxins, heavy metal toxins, pesticides. You saw Kurotola talk about triclosan. That's exactly the kind of toxins we're talking about. Heavy metals and organic man-made toxins. And then, of course, there's the emotional piece. And finally, we'll get into biological. We'll talk about examples, and then we're going to say, why is it that we all behave differently? I may behave a certain way to a stressor, right? If you guys all started booing right now, I might have a certain response, right? It could be run. It could be fetal position. It could be fight, step on those tables and go after whoever started it. There's different ways we do it, right? We deal with stress. And that's no different. So your brain is as unique as your body, and there's no way to know. So you really have to get to know your patients. And one of the reasons we have so many is so you have the tools to do this. And that's when we get to talking a little more about it, those tools come in handy. But everyone is going to detox differently. Everyone's cells are going to behave differently, and it's their genetics, epigenetics, microbiota, brain, and so on. So we're all very unique blueprints. And we don't turn on the same way, and we don't turn off the same way. And I don't mean turn on in any weird ways. We'll get into the SER and peroxisomes. I know now we're getting into the the nitty-gritty cellular stuff. Biotoxins, these are things that we're all exposed to. Xenotoxins, man-made, I mentioned that. So let's start with Mercury the Menace. I want to give you a couple of examples as to why we're approaching detoxification in a relatively complex way, but we're trying to give you the simplest tools to manage the complexity of it. It's no longer simple. If you had someone come to you and they simply had E. coli, everything else around their entire body was absolutely immaculate, right? Their brain was in perfect health, their gut was in perfect health, their skin, their liver, everything was perfect, and all they had was an E. coli issue. How simple is that, relatively speaking? It's easy. Those don't exist anymore. They may have existed, a millennia ago, but those cases don't exist anymore. And the body is doing its best to try and manage the multiple routes, compounded toxicities that we're experiencing. Okay? And so this is one example. So it involves the inhibition of selenoenzymes. I'm not going to go through that, but let's get to the bottom of this. They allow us to restore vitamin C and vitamin E. So what happens when you have mercury toxicity? We now can no longer restore some of the nutrients that we take in. Once you burn it, and by the way, Vitamin C gets converted into the oxidized form in your digestive, whether you want to or not. It has to be oxidized before the cell will take it up and reduce it again. So even though we take reduced or ready-made vitamin C, it gets oxidized before it can be taken into the cell. It's just a process that has to happen. If you can't then convert it back again because you're toxic, doesn't matter now. You now have something that is a causal agent, and no matter how much vitamin C you give them, mercury is preventing that from doing its job. Right? So there's just, these are examples of why we don't like toxins and why toxins become challenging for us every day. And then my story is going to blow into compounding this. And then at that point, it starts inhibiting myelin. Does anybody know what myelin is? Of course we do. So that's why we get these weird mercury symptomologies, don't we? And going back into the time where we didn't even know mercury did this, you've heard of Mad Hatter's disease. We've eroded myelin. So of course you're going to go a little mad, right? So now I want to give you guys a picture of why maybe these things are happening. And we'll move on to, again, the clinical applications. What else does mercury do? Well, it inhibits this crazy thing called peroxisome 1. Don't need to know that, but what you do need to know is look what it's responsible for. It gets rid of statins, gets rid of drugs, gets rid of these aryl esters. These are all things that are man-made. These are enzymes you already have to start to tackle issues that you're exposing yourself to. So what happens now when you have mercury and you're exposed to these toxins? You see our dilemma here? Now we can't get rid of things because of mercury, and they accumulate. Right, there's another problem. It's also responsible for really degrading our ability to modulate endoplasmic reticulum, which we'll get to. And it helps modulate stress. So mercury interferes with stress modulation. The picture I'm painting here is these toxins are cumulative. They get more and more dangerous the more and more you're exposed to them. And you are. All right, let's cruise on. So lead, the disruptor. So it upregulates gene expression. You've heard of epigenetics, turning good genes on, bad genes off. That's the way you want to go. Well, lead does just the opposite. It starts turning bad genes on, good genes off. That can be passed down to your children if you do not fix it before you have children. You can pass those messages on to your children, and then we ask ourselves why we have bad behavior and why we have challenges in elementary schools or why we have weight issues. Why is everything going to the younger and younger generations? This is just one answer to that. This ALD, I don't want to live here long, but ALAD is the enzyme that makes your hemoglobin for blood. So when you have lead toxicity, you're no longer making blood, hemoglobin for blood. So you start becoming anemic. It also is important in ATP creation. So lead interferes with making ATP. And again, not to belabor that, but when you can't make ATP, what's going on? No energy. Now your body's going into that survival mode that we talk about. You'll live, but you're going to shut down all the faculties that aren't required for life, right? So real quick, another lead piece. It gets involved in some more enzymes. There's a message that I keep sending. They keep getting involved in these important, critical processes, which is why we care about them. Intracellular concentration of calcium. Calcium is responsible for all of your neurological messages, right? It is the most important piece to send messages from the extremities of your body to your brain, whether it be touch, sense, smell. All those things use calcium to transfer those messages. And it's not the calcium you eat. It's the calcium that gets taken out of your bones after you've properly put it into your bones. Dietary calcium has to go to the bone first and then to the body. That's your body's choice that it makes. So bones are really it's your inventory that you use. Doesn't matter how much you feed someone calcium, you won't fix this if you're not taking care of the actual issue with lead. Okay? Now, pesticide toxicities. We're moving from heavy metals to pesticides. This is a slightly more complex issue. Why? Because we have adapted many, many ways that we can support using nutrition and herbs to get rid of heavy metals. Why have we adapted these ways to get rid of heavy metals? Why are there all these plants and other nutrients that we can tap into? Glutathione, curcumin, green tea, charcoal, microbiota, probiotics and prebiotics. Why do all these work at getting rid of heavy metals? Why would you already have that ability? Why would the planet already have that ability? Because it's part of life. Lead and mercury and cadmium and all the periodic table of elements have been here as long as you have. So you've developed the ability. And some people, genetically speaking, have a greater ability. If your ancestors came from volcanic islands, whether they be the South Pacific or Iceland, they have an amazing ability to manage heavy metals, right? In fact, there's a snail that they discovered recently on an island that has yet, you can't kill it with heavy metals. It has such a wonderful ability to get rid of them. They keep giving it more and more and more, and it won't die because it's been living among them. Now, you all are not that lucky. You're too complex, and we don't have all the tools, but guess what we do have? We have tools in nature that we can tap into, right? We're brilliant enough to know that. So pesticides, all sorts of problems. I'm not going to spend a lot of time because they run the gamut. How many pesticides are there? Herbicides, fungicides, insecticides. I know Dr. Pomp and I always try to find the number. It's a moving number because I don't think they want to tell us. But it's somewhere in the hundreds of thousands. Hundreds of thousands. And I can tell you from the testing side of things, those of you guys that were in the laboratory, there are pesticides that are allowed. So we in our industry got in trouble for something called prosimidone. It's a pesticide. It kills fungus. It kills things. And they allow it to be sprayed on grapes for wine. Well, it turns out, if you're not looking for these things, which we do, we were trying to source roots from Asia. Well, they don't care necessarily about local pesticide rules. So they're using prosimidone because, oh, hey, look, it's fine for grapes. No, it isn't fine for anything else but grapes. So you got to watch the rules. The rules are, some pesticides are allowed at certain levels in these industries that have been around a long time. Why? Because they've lobbied and gotten it. We in our industry have not ever lobbied for pesticides. We don't see why do you want an acceptable level of a toxin, right? So we don't lobby for that. We don't want that. So we have to test for those and say, no good. Not a good thing. But they cause a lot of damage. They can actually get involved in synapses and involved in all sorts of neurological, and they're toxic very quickly. I have one case, he bit into an orange, the skin of an, do you guys do that? You bite into the orange and you peel it first? You don't take a knife. I mean, who wants to do that? I cut myself every time I do that. Because you cut towards you, whatever. You bite it. He was hospitalized for biting an orange because of pesticides. So we worry about heavy metals, certainly. But I can tell you the future, our new concern needs to be with these man-made for a number of reasons. One, they're highly toxic. They bioaccumulate. They interfere with so many processes. And finally, you don't have all the tools to get rid of them because they weren't here with you forever. They haven't been part of nature. So we're having to be creative about it. We're having to use other tools to get to those. They haven't always been with us. Okay, detoxification. This is the definition. You guys all know this. This is something you've seen before. We go all the way from the body level down to the organelle level. Organelles are a term that we use to define things inside of cells. We have been working in that level for a few years now. We want to work there for you so that we can help explain how some of these amazing products work, these amazing raw materials. So we get all the way down into there for you. Your take-home lesson will be, hey, I heard that, I understood it, I didn't remember it all. There's not a test. If I made a test, you'd have to remember it. Maybe that's what we'll do. But still, it gives you enough confidence to know what we are doing from the beginnings of life all the way to the large, vital person that they are. Now, what happens? I just listed to you all these issues with our environment, our stressors, our emotional stressors, our physiological stressors, our neurological, the heavy metals and so on and so forth. I've listed all those to you and given you some examples as to how they do their damage to you. But now let's take that and we've now compounded it by saying that we haven't all got the tools built into our bodies. Some of us were born lacking certain efficiencies, lacking certain enzymes, lacking certain abilities to take care of these things, and here they are. So there's genetic deficiency in all those enzymes we talked about earlier. You can have genetic deficiencies. What do we call those when we test for them? There's a term that we throw out there all the time. What is the term we use to identify genetic SNPs? Thank you. Those are what we look for. So we can now look for a number of genetic deficiencies, by the way, using SNPs. And guess what? They're related to detoxification. We haven't spent enough time in that, and maybe that's a future talk we can have. We now know a ton of SNPs that affect your ability to detoxify. And we can do that and start to pinpoint what's going on. We can look at mitochondrial issues, which are also SNPs, by the way. They're just mitochondrial. And then we can look at all the other issues that are caused. If someone's already inflamed and you're trying to detox them, what happens? It's really challenging, isn't it? And then when they fail and they come back to you, what happens? You know, I get phone calls. You guys call me next, right? Shayne, what were you thinking? You know? Didn't you tell me to do this? And I won't deny it. But it's tough. It really is tough. So we have to deal with all of these things ahead of time. There has to be a program. There has to be a thoughtful modality from I don't care whether you use kinesiology, whether you use labs, whether you use a combination thereof. Begin with getting to know the patient. I think Mojan said that. Really, really get to know them. If you have a lot of genetic SNPs in these pathways, that's going to show up in behavior as much as it does in their physiology. Does that make sense? Right? You're going to see things about them. You're going to see, some of the Chinese looking at the Constitution. You're going to see body shape, face, and all these things that relate to their genetic background and epigenetic as well. So let's start with that. There's phases. And again, I'm hoping that much of this isn't going to be new to you until we get to the endoplasmic reticulum and the peroxisome. So I'm going to kind of go through these quickly. Phase 1, Phase 2, Phase 3. Briefly, Phase 1 is where we transform them using, it's an oxidative step. So it's highly oxidative. So if you're toxic, you're also creating a lot of free radicals in your body because you're trying to get rid of all these toxins. Can you see how I'm just piling on to the problem? Every time I tell you guys something, I'm not trying to be negative. I'm just saying that you've got issues possibly with the way you were born. We'll deal with that. But now you're exposed to all these toxins. And now I'm telling you that as soon as you're exposed to them, you're oxidizing and you're creating damage inside metabolically, and it just keeps piling on, doesn't it? So don't tell my story like this to your patient because they'll probably cry, and you don't want that. That's stress. But it does. It keeps piling on. We got Phase 2 after that. Phase 2 then takes these oxidized ones and adds things like glutathione, methylation groups, glucuronidation. These are all steps to prepare those toxins to get out of your body. We're done. We need to get them out. We know we need to get them out. How many of you have gone to a restaurant in a bad part of Mexico and had the chile relleno, and you realized pretty quickly that your body wanted that out of your body, right? Okay, it's no different right here. Your body knows. Your body's making the decision. I got to get these things out of here, and I'm doing my best to do it. But I need tools from you as well. That does happen. And so Phase 2 is that. Phase 3 is the final process of getting them out. Let's take a moment, write these things down. All of the processes that I've shown you that are impacted by toxins, emotional baggage, genetics, epigenetics affect enzymes. Enzymes are the workhorses of your body. They're affected by your genes, they're affected by the toxins, they're affected by the metals, the heavy metals. Each and every one of those things typically is an enzyme. Sometimes they're receptors, but more often than not, they're enzymes. Enzymes are very, very sensitive, right? They're like newborns. You have to treat them carefully. We look at this, once all these things are piling on the enzymes, we have to get those guys happy again. We got to start making them productive and so on and so forth. Okay, moving on. Phase of metabolism. I'm going to leave this for you guys to look at, but your body has an amazing ability to do some amazing things in phase 1, 2, and 3 of metabolism or detoxification. Where does detoxification happen in the body? Okay, primarily it happens where first? Liver. Where's a secondary? Kidney, colon, where else? Spleen. What do we look at all the time? Skin, okay? And there's some things that you guys have pointed out to me this weekend that I'm pretty excited about. So, I love the microbiota. I love microbiome and phagome and all that stuff, and we'll get to that later. That's we have babies at Systemic that we're growing, and those are our microbiota babies. There's 13 of them. But that being said, when we look at the detoxification routes, we can start doing what Grandpa did. And that is we can start making triads. There are new triads that we can look at. And some of them are, let me give you one that I think is a new triad. You guys maybe use this all. The gut, brain, skin triad. And the amazing thing about that triad is when we look at neurological health and we're detoxing something neurologically, something that's really deep-rooted, so many times you hear back from people about how their skin changed, rashes, and so on. That's because it's connected. And guess what else? So is the gut. Name a condition that is plaguing young people right now. And it's growing. It used to be rare, 1 in 100. Now it's 1 in 10. Autism. What is one of the most predominant factors of autistic children? Gut. Their gut. It's not just mental behaviors, their gut. And when you look more deeply, you also find skin. So I think there's a triad there. This is the glutathione pathways. We love glutathione because it's an amazing molecule, and we'll come back to this later. This is the phase 3 antiporter. Real briefly, what phase 3 is, in all of those tissues we just named that give us detoxification abilities, phase 3 is the actual get out of here. Phase 3 are all these portals in your cells that say, get the heck out. I want you out. They're the ones that excrete it into the tubules and out of the kidney, into the bladder. All the cells that do detoxification have a phase 3 capability, getting it out of the cell into some moving system, whether it be lymph or blood, to get it out of your body. That's phase 3. These are the enzymes that are involved, some of them. I mean, there's hundreds and hundreds. I want to focus on these because when we get back to how we affect the positive change in these are some of the ones we've looked at to target, right? To help, to give the benefit of getting this job done. So where does it happen? You know the tissues. In those tissues, we have cells. How exciting is that, right? We all know we're built of many, many cells. And the brilliance of that is we all start as what? One cell. We all start as one cell. And I think that's pretty amazing. And now they're finding, by the way, that there are mitochondria contributed by the sperm. That's brand new. Now we got to ask why those don't stick around, right? Most of the DNA we find is the mom mitochondria. The dads also contribute mitochondria through the sperm. So there's some really fun things that happen early on that they're mysterious, but we'll learn more. We start as one cell, and in that process, we also get these from mom. So mom contributes the smoothie R, and the smoothie R is 50% of the membrane of a cell is the smoothie R. How many times have you heard Dr. Papa talk about get your membrane healthy? Have you guys ever heard that before? You've heard it by many of us. I think it's his mantra. The smoothie R is 50% of the membrane in an entire cell. And guess what? In liver and in kidney and in skin, we can actually watch it grow real time when I stress you out. If I were to yell fire, or if I were to spray a can of, off in here and you guys all freaked out, your smoothie R would start to double immediately. That's how amazing your body is. Why does your smoothie R double so quickly? Well, like I said, it's the 50%, and it's responsible for making these, but the reason it doubles so quickly is look at this bottom bullet. Look what happens in the smoothie R. Someone tell me what that is. That's your phase 1, 2, and 3 I just described. It's all happening in the smoothie R. So I know you guys can think about this big. Detoxing a human, let's focus on the skin, the liver, the kidney. Okay, there's cells in each of those, and there's lots of different kinds of cells in each of those. I don't care where you dig deeper, deeper, deeper. When you see an organelle inside of a cell called the smoothie R, that's where the magic happens. That's where detoxification is happening. Okay? Now imagine the importance of getting nutrients into those guys. First of all, we have to get nutrients into there. Secondly, we've got to get all the toxins out very efficiently. That's why you're here. That's why we're here, to support the pieces that need the support the most. And the smoothie R is one of them. And I want to just say as a side note, have you guys heard of mitochondrial dysfunctions? Did you guys know that mitochondrial dysfunctions happen because of smoothie R dysfunctions and peroxisome dysfunctions? It's all happening in the smoothie R. That's where all the nastiness is going on. That is the nuclear power plant, or whatever terrible, visual I can give you. It's all happening in the smoothie R. They're next to all the mitochondria. If there's a leak, if there's a damage, if there's free radical oxygenation, the free radical issues going on in the smoothie R, guess what happens? It bleeds into the cell, damages the mitochondria, off we go. More often than not, the smoothie R is the problem for so many people. And it makes sense, right? Because it's the one doing all the dirty work. Yes, there's a little bit of oxidation created in the mitochondria, but the mitochondria has most of the tools to handle it a lot of the time, unless you have some issues. But the smoothie R it's where all the toxins are. They're concentrated in that organelle. If the membrane breaks, if anything happens there, we got a problem. So the smoothie R is the unsung workhorse, but he can be the Trojan horse in that case. So we care about it because that's where all the detoxification happens. This is what it looks like. So you guys have all seen images of cells. You've seen the smooth and the rough ER. We're not going to talk about the rough today, but the smooth is where that's happening. I also want to start to talk to you about peroxisomes. These are other organelles that are membrane bound. They have this little membrane. You're found in all these same tissues, specifically in these detoxification tissues, like we forget the lung, but there's of course, liver, kidney, and skin primarily right now. Brain as well. Peroxisomes. I want to tell you, again, I believe, and it's the first time I've talked to you guys about this, and I don't know if you've experienced peroxisome education before. Probably not, because it is so probably boring and detail and minutiae. I get it. But what I want to clarify with you guys is that, it's a very, very critical part of keeping your cells happy. And then happy cells make happy tissue make happy organs, so on and so forth. Peroxisome. But look what the peroxisome does. It is responsible for fatty acid beta oxidation and alpha oxidation. Why is that important? What is one of the diets that is improving the health, especially neurological health and other insulin health of people right now? Ketones. Guess where they're made? Okay. What else does it do? It does a lot of things. Viral innate immune defense. So all of your innate immune leukocytes, okay, their peroxisomes are very, very, very large and abundant. Why? Because the innate system is responsible for getting rid of viruses. That happens here in the peroxisome. So if you're toxic, guess what? We're immune compromised at that point. What else is going on? Thermogenesis. We deal with that. Lipid biosynthesis, and so on and so forth. You see so many things. Purine catabolism. The other thing it does is it's responsible for your oxidative reductive stress balance. The redox potential all happens in the peroxisome. So if you believe someone's redox potential is off, it's their peroxisome that's off. So we want to nourish this. Okay, so these are a couple of articles I want you guys to see where I'm not just quoting hypotheses and theories. These are things where you see it's really happening. People are really starting to study inside of the endoplasmic reticulum and the peroxisome and showing that they're related to toxicity and stress. We all respond differently to these. Our epigenetics, genetics, combined toxic load, and emotional toxin load, and dysfunctional detox all contribute to the individuality of that person's status when they come to see you. You've got to work through all these different pathways to get them fully out of it. And some of these things, I think someone this weekend has mentioned that it can take 9 to 18 months before you reverse some of these damages that have been created through the toxic load process. These factors are all part of the process. I told you about all the enzymes and how they contribute to detoxification. We can get things bound up. There are ingredients we can use to bind up toxins. Have you guys ever heard of retoxification? How you can retox people? How does that happen, by the way? How do we retox? How do we reintoxicate? And I don't mean going out the next night after you've been drinking. Okay? That's right. There's two factors. One, you release a lot of toxins after you've released them out of your liver, gallbladder, into the colon, right? When you do that, it's in bile. It's usually in bile salts. A lot of times, genetically speaking, you can uptake those if your enzymes and your bile isn't made properly. Oh, by the way, bile is made in the peroxisome. Okay, that's where bile is made. So it helps deliver toxins out of you. Should have mentioned that earlier. But you have microbiota issues. Now we're finding that if you've got dysbiosis, you're reintoxicating because all those methylated, glucuronidated, glutathione conjugated toxins, well, if you got the wrong microbiome, it clips all those off and you absorb them right back up. And now they're in the portal vein. And so you just reintoxicate every time you do it. And that might be some of the challenge you're having. So you got to fix the microbiota. So let's review. We can work at this level. I haven't told you exactly how yet, but we can. There's a number of raw materials that we can deal with. How do we work at that level? Membrane, methylation, glutathione, mitochondria. We can provide genetic or epigenetic nutrition. We can stimulate epigenetic changes. We know that now. We can support telomeres. Didn't get into why. Neurological nutrients compensate for polymorphisms, which in other words are SNPs. And then finally, we can deal with cellular metabolic issues as well. Why do we care? Hopefully you guys have at least experienced some of the early stories we talked about up here today. This is the why. This is why we're doing it. No one wants to live in a toxic relationship, whether it's with themselves or with anybody else. I'm going to show you why we've looked at this complex issue and tried to simplify it. Again, it doesn't matter where you approach your patients through questionnaires or kinesiology or blood. That's any one of those work from our perspective, and we can tell you why in a minute. The research that we do and so on, real accountability and our passion is certainly here. Hopefully you guys figure that out. So let's take a break for 1 minute. Not a break, I'm just saying, shake. Where's that rubber bands, okay? I know it was a lot, okay? Do a little shimmy. Now we have time, we have a little bit of time to get into some clinical stuff, guys. So, clinical things, what I want to start now is looking at these packages. What are packages? What do packages do for us? So many of you that use kinesiology, so many of you use lab tests and so on. Detoxification, I said, if it were simple, then when your patients go on the internet and say, hey, look, there's a bottle that I found as a liquid, and if I drink it every 10 minute, 23 seconds, I'm going to be good. I'm going to be all fine. That's what it says right on the label. If things were that easy, we wouldn't be here, right? If things were that easy, we wouldn't have to worry about. But why isn't it that easy? What I just told you. You've got your biological interferences. You've got all the toxins you're exposed to. You've got your genetic predisposition. You've got your cellular issues. That means it's a complicated process. It's a very complicated process, and I want you to at least get your mind around that. Now, that's been a challenge for people like Dr. Pompa and many of you over decades. Why is it that what used to work 20 years ago doesn't work anymore? And I know a lot of you guys have realized this yourselves. I'm I'm living a certain lifestyle, I'm eating a certain diet, I've now changed my diet. I know a lot of people that went from a moderately healthy diet to gluten-free, dairy-free, meat-free, and still didn't feel good. Did they feel better? Yes. Were they thriving? No, they weren't. Because it's not a simple one-product solution. And again, whatever modality you choose, these packages work, and the packages have now seen, I did the estimate the other day. So what do I mean by packages? We call it prep phase, body phase, and we're going to focus on brain phase, those three. These were born out of the concept that 1 or 2 bottles wasn't working. And even if you start somebody on one spectrum of the process, whether you start them with mitochondrial health or energy, by the time you got to the microbiota, you were back again, and you're back and forth and back and forth. And we struggled with that. So these were born out of that. This was a project really conceived. We were getting into packages, but Dr. Pompa approached me and said, we're not succeeding in all the other simplistic ways. We're not succeeding with 1 bottle, 2 bottles. We're not even succeeding with 3 bottles. And Systemic had the powerful tools of things that went all the way back to Grandpa, Stu, to present. And when you combine all those, you cover the gamut. You cover ancient healing technology up to current healing technology. And that's really what is here. And I have a game for you in a second. So I want to say that it is a complex issue. It has a complex etiology, has a complex epidemiology, and so on. It's very complex, detoxification is, because it comes in so many forms. However, we've tried to take that complexity and to our best of our ability, put it right here, which is why it isn't just simple. It's not just 1 or 2 bottles. It's a lot. It's a lot of different things. It's a lot of different timing, and so on. And this has gone through iterations. So 2 takeaways. 1, you start with complexity, but you get it in a simple way. How is it simplified? It's a packet. Do you guys remember our earlier packages? Did you guys ever try our earlier packages? Even our GI Wellness, GI Purge. Have you guys tried those? Did you guys ever get lost on the way? Wait. Is this morning? Evening? What is this? Do I need to do this now? Oh, if I take it now, what's going to happen? Bind complex to that, right? So that's one simplicity. Dr. Pomp has added another simplicity through something he'll hear about later, which is an educational portal that he has. I should say him and Warren, not just give him credit. But then finally, you can take this, and this is the starting point. The starting point is simplicity. Can you build off of it? Let's reflect back to the other speakers. Let's reflect back to Hank Williams. All the work he's done for you guys, right? If I start here, no matter what my modality is, if I start here, because it's simple, there's compliance, and all of us need some form of detoxification at some point in our 3 months, 4 months. I wouldn't even go that far. Maybe every quarter, twice a quarter. You have simplicity first. But with the tools you're learning over here, can you add to this? Okay, let's do the quiz. Can we add to this? Can we say, these are research, how you guys don't even know about that now. Let's say we're working on phase 1, 2, and 3, and we're using, what works on phase 1, 2, and 3? Where is those tissues located? So what packages do you think contribute to phase 1, 2, and 3 health? Yeah, look at that. How amazing is that? Liver, kidney, mitochondria. So can you guys see the intellectual design here? Why they're designed the way they were? Why we're tapping into Grandpa, later Stu, and now the youngies, Nicole and I, tapping into that systemic world, because detoxification can no longer be just 1 or 2 bottles, right? Drink a bunch of Coke, swallow a bunch of olive oil. You guys remember that? Yeah, and get a little green poop, right? The poopy diaper. We're back to the poopy diaper, and it's not even a microbiome conference. How terrible is that? Let's look at this one. What about MORS? What about, not MORS. What about SER, peroxisome, methylation, ATP? Can you guys kick me out some ideas there? What would really help the SER? What did I tell you it was made of? Membranes. So what do we do? right there. You'll notice Vista shows up in a few places. What about the peroxisome? What do we think helps that? What do enzymes need? What are the two things enzymes absolutely need for life, which is why we call them essential nutrients? What are they? What categories are they in? Vitamins and minerals. Vitamins and minerals are what are needed by all your enzymes. Well, notice there's min, there's spectra, there's mores. So these things contribute to various aspects of what you've just been taught today. The peroxisome and the endoplasmic reticulum. So from here forward, I don't want you to think of detox as just a way to de-stress the body. The thoughtfulness that have gone into this has been really, really deep. We've thought about all the organelles, what they need, how they work, why they need it, and why you're probably not getting it in your everyday diet. That's the thoughtfulness here. And again, no matter what you do, I think you can start here. This is a place you can start. And for those of you that are really starting to understand our product line, you can add to this. So now the next part of our quiz is, if I wanted to further support my detox process through the adrenal axis, what else should I add to my protocol? What if I think my adrenals are also struggling at the same time as I'm detoxing? GA. So do you see how it's easy to bolt things onto this now? Make it really simple for you to customize and personalize your process. That's key here, because not everybody's struggling with the same issues at the same time, and so you personalize it. How else can I quiz you? What if I thought I was highly inflammatory? So I'm extremely inflamed, and it's generic inflammatory. It's really autoimmune inflammatory. What else can I add to my protocol while I'm doing this? And Dr. Pompa will hopefully get a chance tomorrow to give you some case studies of how he bolted things onto it at very specific times as well. So you got to take notes there too, okay? But I want to deal with inflammation while I'm detoxing. What should I bolt onto that? Fire sedate. Anything else? Sorry? RPM, thank you, awesome. Epic, perfect. Rocks. ALG, yeah. So these are things that you guys, I'm hoping that you get the picture. These are things you can add to it. And again, how would you do it if I'm a kinesiologist? What would I do? I would muscle test those formulas. I would look at what they might need in addition to this. I've been with you all long enough to know that compliance is a very challenging piece to what we do. That when you cannot keep them compliant to your schedule, they're not getting better, and we don't have the luxury of having immediate results, right? This immediate society. We need them to stay compliant for a period of time to start really experiencing the changes that are permanent, that are amazing and permanent. So that's critical. That's the detox. And again, you're going to hear more about this tomorrow, thank goodness, from Dr. Pompa, because I know I've given you a lot. But the reason we had Hank do what we did for you this weekend is to give you all of the background of everything we have. We can do it with all of these things. It's possible. It's an amazing tool when you add to the other tools. Okay. I'm going to jump on you guys now. And we're going to change gears one more time. Prebiotics. I'm going to go through a few prebiotics. Now, prebiotics by themselves, we don't think of as detoxifiers. What are prebiotics? Why that term? Yeah, it's stuff for the bugs to live on and to create a lot of immunological health through the microbiota. What is a good example of a prebiotic? What is our prebiotic? Fiber. Yeah, FBR. There are others. There are many others. Your diet contributes a ton of those. Prebiotics do fill that niche. How am I looking at prebiotics as a detoxifier? That's the question. I want to stay in the line of detoxification. This second half of the talk will be a bolt-on concept, a concept we're going to bolt on to this. Does that make sense? It's an add-on for people that are struggling with certain conditions. So let's hit this hard, because I know I'm doing okay on time. All right. Our objectives today, dysbiosis. That is an issue. You've heard of SIBO, you've heard of IBS, IBD. These are all GI-type dysbiosis. There's skin dysbiosis. There's urogenital dysbiosis. This short definition is the microbiota that live in that environment can be either in a state of good environment with the right microbes really occupying the right niches, producing the right materials, the vitamins and minerals for you, or they can be overgrown, like weeds in a lawn, or they can be filled with pathogens. There's a lot of ways to describe dysbiosis. Needless to say, dysbiosis is one of the core issues in our health. And why it is because it's the first place that toxins and other issues impact you. Because your microbiota live in your lung. Anything exposed to the environment is where microbiota live. Skin, lung, your GI tract, and your urogenital. And just yesterday, we talked about it being in the eyeballs. Anything exposed to the environment has a wonderful potential to be a nice, harmonized group of microbiota. When you disrupt that with toxins, with any other toxic insults, you create a dysbiosis. Dysbiosis then is the beginning of the end for health. Okay? So in our case, let's focus on E. coli, Salmonella, and Pseudomonas. These are pathogens. Do pathogens come into our world and disrupt our nice eubiosis, which is good? To dysbiosis, yes, they do. What do they do when they disrupt it enough that we get sick? We call them pathogens. We call that an illness. We call that an acute microbial illness. Can they do it slowly? Can they do it where it's not so abrupt and dangerous? Have you heard of that? Have you experienced that? Yes. And that's probably more often than not what we experience, minus the food poisoning, the acute situation. We experience these low levels. The most, I guess, glaring example would be a low-level UTI. Right? It's persistent. It's reoccurring. It comes back often. That's E. coli. That's Pseudomonas, generally, those two. So it is an issue for us. We're going to talk a little bit about phagome being part of the virome. These are all ohms. Are you guys okay with ohm words yet? You've seen them enough? What are ohm words? They describe large genetic groups of organisms. Phage, virus, bacteria. There's a parasite ohm, right? There's a fungome, right, for fungus, and so on. So there are all these large groupings of genetic material. Why? Because right now we're studying them using genes, not using any other tools, so we call them the ohm. That's the omics. You guys all have a genome. And then we've got some issues at the end when we get into clinical questions, I hope. That's my goal. So now these toxins, whether they be low level or high level you get this immediate body response. You want to evacuate, whether it be a toxic experience. Acute is dangerous. That's the one you really want to take care of quickly. The low level chronic is another story altogether. But there are 220 known bacterial toxins. And 40% of them cause disease, and they damage us. They're designed to damage us. And that's what they do. What kind of toxin targets are there? There are all those neurotoxins, enterotoxins, cytotoxins, hemotoxins, and so on. So they damage a lot of our tissues. And many of you experience that in your clinics. When you have damage to your tissue from a microbiological or fungal or any other, it can be long-lasting. It can take a while to repair that tissue, right? It can be extremely scary and dangerous and so on. And some of the tools we've had we're not very happy with because they're creating issues in our life, like antibiotics. Antibiotics are starting to create issues surrounding our resistance genes that they're getting. Has anybody had a chance now in their lifetime to experience an antibiotic resistance in their patients where they came to you and they could no longer take antibiotics? Has that happened to you guys yet? Yeah? Raise of hands. Okay, that's pretty incredible when you think about it. We can't keep tapping into antibiotics. It's not going to keep working. There are scientists feverishly trying to find them on the planet, and they're coming up empty-handed. We have to look at alternatives. And right now, the only alternatives that exist are in your guys' world, our world. Right? Pharma doesn't have an alternative at the moment, which is why they have just accepted fecal transplants without question in hospital ERs. So if you go in with C. diff, they're allowed to give you a fecal transplant without FDA approval. FDA just said, forget it, do it. We're no longer going to go through that 10-year process of approving it because it works. It works for those cases of C. diff. So we're starting to really see some successes in our world. Pathogen dysbiosis. It affects the skin, UTI, gastrointestinal tract, and so on. So we all know the symptoms, or you've all seen these symptoms. They can be, again, they can come and go. They ebb and flow. They become difficult to track sometimes in people that have low-level infections. How can we have a low-level infection? Right, that's dysbiosis. That's one example of it, where they're living among your good bugs, but they haven't quite invaded your tissues. That's low-level infection. What's another example of low-level infection? Have you guys heard of the, teeth? Thank you. Teeth's a great answer. Teeth can be a low-level infection. You guys remember those cavitations? That infection can be there for years, and it causes brain issues and bone issues, and those are low-level infections. These organisms are found in those sites, among others. There is another low-level infection, I think, that you guys experience quite a bit, where these organisms get into us. They might get into systemic tissue. They're certainly in our GI tracts and maybe in our urogenital. But as they sit and secrete toxins, you experience good days and bad days. You experience different symptoms that you think you can pinpoint, and then they go away. And then they come back. And one of the reasons for that is it's your immune system. As your immune system might be weaker or stronger, depending on the rest of your environment, what's going on, depending on how toxic you are, and et cetera, you'll start experiencing more of these bacterial invasions. These guys are all opportunistic. And if you don't believe me, I know each and every one of you have likely experienced where the immune system drops, and now something that was otherwise unknown is causing an issue with these people, right? It's risen in the ranks of being a problem, whether it be E. coli, salmonella, or a parasite. Parasites, there was a statistic thrown out yesterday, but even the CDC recognized there are 65 million Americans that carry parasites. How do you think we carry those without all of us dropping over dead? When you're healthy and non-toxic, you keep it at bay. You keep it at bay, right? When you're toxic and your immune system starts to fail and inflammation starts to rise, they take off. They come to you and they say, I don't know what's going on, but I am miserable. That's what happens. All right, moving on. Escherichia infection. So I'm going to give you the process of a couple infections just to show you how insidious these guys are and why when people come to you, you might see how much pain they're in and whether it's low level or high level. It's an issue, and they're very, very creative, so we need creative tools to go against them. These are the different hemorrhagic type E. coli. They're everywhere. They account for a lot of our foodborne illnesses. How many of you guys like to eat organic? Yeah. Do you think we expose ourselves to these things? Yes, we do. Why? What do they use to fertilize organic material, organic food? Manure. At least half this room will carry these kinds of guys. Sometimes we keep them at bay, just like H. pylori. Other times we carry them as a low-level infection. Other times it's a higher level. There's a gamut. But we are exposed to these all the time. It's very clever. We've talked about years about the microbiota and tight junctions and the blood-brain barrier and so on, right, and skin tight junctions. Pathogens can sometimes initiate the cascade that ends up in mercury toxicity or lead or pesticide. Why can they be the trigger for it? Because all three of these pathogens we're going to talk about today, Pseudomonas, Salmonella, and E. coli, open up your tight junctions. It's what they do to get into you. So they secrete all these proteins and toxins that open up your tight junctions in your GI tract or your lungs or wherever they end up. And they send all these signals to say, go ahead and open up. Why? Because we want you and all of our friends, all of my siblings, because I'm gonna reproduce every 90 minutes to get into your bloodstream. That's how they do it. While they're doing that, you're driving through LA and breathing, really some amazing things in the air, or even Salt Lake in the winter. Now you're allowing all these things to enter. They're entering without regulation. They're getting in. So low-level E. coli, Salmonella, Pseudomonas open up tight junctions. So it's not just chemicals that open tight junctions. It's these little guys, and they do it in a way that you don't even know what's happening. And you're going to see that's a theme throughout all three, even though I'll show you slides on all three. Well, what are the results? Well, sometimes you get immediate results, right? You get inflammation, and when they get in there, they start to inhibit what else? They start inhibiting enzymes in your body. Enzymes, there's a central piece. That happens. So that's what they do. Salmonellosis. Now we're getting onto salmonella. There's a lot of salmonella that we never diagnose, and we can't truly do it unless you were to get a sample. But low-level salmonellosis is the same thing. You open up tight junctions, you don't feel well, there's all the symptoms that we talk about when we have GI issues or lung issues where they can get in and start opening up these junctions. Same thing, as I mentioned, they open them up, the toxins get in there, and they open them up. Now, some other interesting tidbits. Remember I told you that the peroxisome and the ER is responsible for detoxing and the redox potentials to keep oxygen radicals down and protect all your internal organs like your mitochondria and so on, internal organelles. Turns out that bacteria, like these guys, these pathogens, they find tools to specifically target those things. Why do you think they do that? Why do you think they go after the very organelles that are responsible for getting rid of them? I mean, it's like going after, the command center of a ship or something. You take out the command center, it helps you survive. So the challenge is they're slowly taking out your command centers of every white blood cell that comes along. It helps them survive longer and longer in your system. So I know these slides are complex, but the point is they get in, they disrupt. So this would be the lumen in the gut. This would be the the lumen. These are the tight junctions. They find a way in. They can actually get even phagocytized, go into the tissue, and then break out after they've wreaked havoc and move on. And once they're inside, then they can float around, cruise around in the blood and cause all sorts of problems. Some of these guys can form biofilms, some don't. Not every E. coli is created equal. I want you guys to remember that. When we get into probiotics later, here's a little lesson for you. If I say Escherichia coli, that's just one. I can have Escherichia coli N3. I can have Escherichia coli O17H7. I can have all these other Escherichia coli. So genus and species doesn't tell the story. You have to know the detail after that, the subspecies, in order to really understand what these guys are doing. And that's important for later when we start talking about more probiotics that we're dealing with. When I say Lactobacillus casei, that's not going to be enough. You need casei plus something. Okay, so now we're getting more detailed names as we're getting into this science. Sorry, it's a tangent. Pseudomonas invasion, same kind of thing, right? They invade. They bind to your cells. They figure out what's going on. They open up junctions, and they escape into your bloodstream. And then, of course, the pathogenesis of Pseudomonas, which is slightly different, and we're going to spend a little more time on today. Notice where it gets involved. So Pseudomonas aeruginosa becomes a problem when you have a wound, becomes a problem in the eyeballs, becomes a problem in cystic fibrosis, becomes a problem in burns, and UTI. So Pseudomonas is my focus today. What else is UTI? What other organism do we worry about? Escherichia coli, EC. But now we have Pseudomonas. We're looking at Pseudomonas because when you see, let me tell you one place where you get it. If you go swimming in swimming pools or you sit in hot tubs, and you get out of those places, and the next day you have a rash or you have a lump, that's Pseudomonas. When you're healthy, you've got about a 2-week recovery time. If you're not healthy, you could be dealing with months and months of issues with that little bug. It's very invasive at that point. So there's our Pseudomonas pathogenesis. So aeruginosa. it is again, it produces toxins, endotoxins, exotoxins. This is what it acts on. It acts on your immune system and so on. I'm not going to go into that. It's a type 3, again, not important here. But what that means is these bacteria have a fang that they stick out, and it punctures you, and then they inject you with the toxins. That's how it works. Kind of clever, don't you think? I mean, insidious, but clever. And that's the type 3 injection system. So acute versus chronic. I've kind of gone over this a little bit for you already. But it's important to note that when it's chronic, they live amongst the other microbiota, and your immune system doesn't have a ton of access to them because they're living in the lumen, they're living in the mucosa, and they're just kind of out of touch in many cases. So you know they're there, they're secreting toxins, low-level toxins, they're getting into your bloodstream, and you keep experiencing these symptoms. Periodically, sometimes they're more intense than others, and so on, okay? Well, they also secrete something called lipopolysaccharide. Have you guys heard of that term? A lipopolysaccharide is a component of a bacterial cell that breaks off and gets into your body, and your body initiates an immune response. It's one way to trigger an unnecessary autoinflammatory issue. So again, I'm going to go back to, we have a lot of inflammatory issues that we deal with in your guys' world and mine. But lipopolysaccharide can sometimes be the trigger. So now again, I'm going back to this idea that dysbiosis, when dysbiosis involves a pathogen, that pathogen then can secrete these LPSs, which create inflammation that causes you arthritic. You can have type 2 diabetes occur from this. You can have non-alcohol fatty liver disease. These are all started here with this guy right there. It's subtle, but it happens. And it happens more than we think. Why? Because it is so subtle. Right? If you look at it standing back, you're going to say, well, these guys have an inflammatory disease. Let's deal with the inflammation and so on. I want you to ask yourself, are there a pathogen? Is there a dysbiosis? While I'm detoxing them, how about we take care of the pathogens? Can we detox and deal with pathogens simultaneously? Yes, we can. Do you have to be careful? Yes, you do. And again, I hope Dr. Pompa will give you more on that later in a little while. So LPS is also an insidious, low-lying inflammatory marker or causer. So what's the caveat? We're going to be talking about phage from here on out. I've told you about the organisms, the bacteria that cause the issue. From here on out, we're talking about phage. By a raise of hand, how many people have heard of phage? Oh, you guys are brilliant. How many of you have heard of phage here? But you have heard of phage elsewhere. Yay. Where? Just in your reading? Oh, well done. Proud of you guys. Is there a country that is a little more premier in phage you guys are aware of? Russia? Yeah, Russia, Georgia specifically. They've been using phage a lot longer than we have. However, we've now brought phage to the forefront here, and as I get through the phage, there's 3. And you can imagine where there are 4. Imagine how we use them. And these phage, of course, are going to offer us a lot of potential. But I want to remind you that phage are extremely specific. Extremely specific. E. coli pathogenic phage will only kill pathogenic E. coli. Pseudomonas phage will only kill pathogenic Pseudomonas. And salmonella phage will only kill pathogenic salmonella. You guys with me? They don't cross over. Right? They're not a shotgun, or excuse me, a machine gun approach. They're very targeted. Okay? Now, why am I calling all this probiotic? Or prebiotic, sorry, thank you. Why am I calling this prebiotic? I'm reaching into your cleverness now, because I have to be clever. Why would we call it a prebiotic treatment? Where am I worried about these? Yeah, thank you. There's one. I'm going to repeat what he said in just a second. Why am I worried about these organisms, the Salmonella, E. coli, and Pseudomonas? Where are they locating, and what are they doing to me in my presentation? The gut. What are they causing? Dysbiosis. What do we use to prevent dysbiosis in many cases? Prebiotics, right? We want a healthy microbiota. The other reason is because they're not a drug. If I were to say, use this because it treats this, that, and the other, that's a drug. We cannot use phage as drugs. We have to use them as a natural product, meaning we have to change the environment that we have in our systems, and one way to do that is phage. Okay? That's why. Those are the two main reasons for that. Is there a phage for every pathogen, by the way? I mean, theoretically? Yes, there is. There absolutely is. So again, now let's revisit those. I just revisited this with you, how they harm us. The phagome. Ohms, ohms, ohms. Get used to it. Does anybody here not like the ohm world? Get over it. Okay? Ohms are here to stay. The genome, the microbiome, the phagome, the virome, the parasitome, the fungo. It's going to keep going. Okay? It's going to keep going. Get used to it. Get your brain around it. The other terms you're going to hear a lot of is iota. So there's the microbiota, which are the living organisms. The microbiome is the genetic material. Just to help confusion. Or to confuse you more precisely. So that's where we're going with this. We're going to go and look at the phagome. What else is in the virome? Do we have other viruses among us? Many, 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 many viruses. We're specifically going to be talking about the phagome, though, because these are the viruses that only attack bacteria. Other viruses are a problem for us as humans. We're not going to talk about those today. Okay. They all were born out of the Microbiome Project, of course, the human project. And the more we keep doing this, and we're looking at the skin, oral, nasal, GI, vaginal, or urogenital, we're showing this pathogenic load. Now, have you guys been talking about the pathogenic load as clinicians for 50 years-ish? I'm going to say with a resounding yes. Yes. Say yes. Here's where we marry two concepts. We're marrying science with our traditional energetic healing. Why is that? Because you have been preaching these pathogenic loads, these low-level pathogenic loads for a very long time, and now science has caught up and said, guess what we're finding? We're finding the actual low-level pathogens. Because before this, if you had a microbiological contamination, you were sick, you were in the hospital, you were getting IVs, that's how we thought of an infection, right? The infection. It's these low-level issues that you guys have been talking about for decades that we're talking about today. The acute stuff, the stuff that hospitalizes you, that's a whole different ballgame, right? Tuberculosis and so on. Those are different. These low-level have persisted, and no one's talking about that elephant in the room. All right. We have them. We know they're there. Now that we're studying the microbiota, we're finding that. We're finding all these guys, and we're saying, whoa, we had no idea they were there, and causing this low-level toxicity and going on, right? And that counts for fungus and parasites, okay? All right, this is a picture. No, not necessary. I just mentioned that they're everywhere. These are all the virome deals. Hopefully you can read that in your notes. If not, I can get that to you. But that's all the stuff we're finding. The Microbiome Project is finding more organisms than we knew existed. We are finding things like you would not believe. The publication's coming out, hey, guess what I found? Hey, guess what I found? Hey, guess what I found? That's what everybody's saying. Hey, guess what I found? Because they're finding things every day. Amazing things, too. So there's your virome. So this is the beginning. Look how many. And these, I want you to keep in mind that we talk about how there's 100 times the genetic material from bacteria on your body. Do you want to guess how much more there is of viral DNA material, RNA material? Times that by another 10. That's how many viruses live on you and in you and around you and on your eyes and on everything else. And in fact, thank you for whoever it was. I think it was Joy Watson. Someone thanked Joy Watson for me because she said, Shayne, why doesn't somebody look at the eyeballs? I think it's a brilliant idea. I have yet to see a microbiome paper on the eyeballs, and I can promise you it's loaded with microbiota. We just don't know what it is. I'd be willing to bet that very few people are looking at that. but it's something we can do. All right. What's the potential? You guys, the potential has been realized in places like Russia. And we are tapping into this potential just right now. There's what they look like using scanning electron micrograph. You guys ever play with that? No, I've only done it once, and they're brilliant. They're fun. No, this right here is a bacterial cell. This is what the little phage look like. This is E. coli, by the way. E. coli phage. Miravodier. Look how cute they are. They're like the lunar lander. Now, you can actually see these guys in action. I can't really see it on the slide, but this little lander, he's actually injecting his DNA right there into the bacteria. And what it does, as soon as it gets into the bacteria, it sends a signal to all the bacterial machinery saying, make a whole bunch of these guys, because that's how he reproduces. So the DNA goes in, he makes a whole bunch, and he makes so many, the bacterial cell actually fills up and then bursts, and thousands of these guys come out. That's how they work. Okay? The phagome, once it was discovered, now we've always known about phage, but we didn't realize that we were a reservoir of phage until the Human Microbiome Project. We thought of phage as being kind of a transient little viruses that run around the world, and occasionally you come in contact with them, occasionally you don't. They live in the oceans, they live in the rivers, they live in the sewers. And speaking to Nicole's global theme this weekend, our phage are derived from sewers around the globe. So we take human waste from around the globe. Not we, there's a group we're working with. And they have literally bottles of human waste on their walls from just about everywhere I can think of on the planet. And that's when we look in those human waste pieces for phage. And that's where we find these. So the ones you're going to be eating came from human. Okay? It's all good, though, because they were in there doing you good, and they're going back in you doing you good, right? I mean, that's why we have them. They are one of the... Yeah, I'll get to that. Yeah, no worries. But getting back to the phagome, you guys, we know the phagome, when you look at infants, when you look at newborns, even C-section, when you look at their microbiota, and you guys have talked about this before, we've talked about this before, that we get inoculated pretty early in life, and a vaginal delivery changes dramatically your microbiota compared to a C-section and so on, right? Well, the phagome, right so far, as of today, and it's just barely starting to be studied, it's one of the latter microbiota pieces, we're not finding phage on newborns, but a week later, they're covered. So it takes 1 week hanging out with mom and dad and sisters and dog. Their phagome is now huge, right? It takes about a week for that to happen. I can tell you one more little side note. It's more sensitive than the microbiota. So getting back, I'm going to jump back to this, you guys. When you're toxic, and it's a hypothesis, and we will prove it eventually. We will prove the hypothesis eventually, and I think Dr. Papa would like to work on this with us. The phagome takes the first hit. They're more sensitive than your bacteria. So when dysbiosis starts, by the time I think you're in microbial dysbiosis, you've already killed all the good phage you had. They're more sensitive, okay? Which is why when you taste the phage you've got, that's the only liquid it likes to live in. And it's just like the ocean. It tastes like the ocean, essentially. That's what its favorite little liquid is. But it takes the first hit. And we now have studies showing, and I think I might have given you some, that when your phagome takes a hit, that's the canary in the coal mine. Next, it's going to be your probiotic, your bacteria, your commensals, and then it's going to move into your tissue. So that becomes the first line of, guess what, something's going wrong with our microbial environment. The phage take the first hit. We'll get more into that, hopefully, with our work. But this just shows you how it changes as you go from a child to an adult. Early phagome, I already mentioned this. Colonization happens really rapid. It's like 1 week after birth. And similar to the microbiota, it's less diverse in a healthy adult than it is a young person, right? It changes over time. We don't know why yet. But we can predict, right? And the more toxic you are, the fewer diversity of phages you have. All right, phage-immune interaction. So it's 10 to the 15, so it's a quadrillion phage. That's not even a number, right? Quadrillion. That's how many you have on your body right now, or you should as a healthy person. 10 to the 15, that's 10 with 15 zeros behind it. It is the most densely populated ecological niche in nature, and it's on you. How cool is that? It's more dense than anything else on the planet, is the phage living on you. That's pretty amazing. Go back to Kuratola's, breath. Go back to, every talk you've heard today. This diversity is pretty amazing in this world. The gut microbiota impact on the host microbiome, it's amazing. Now there's a phage for every good guy and every bad guy. So your healthy phage keeps good guys in check as well. There's a phage against Lactobacillus acidophilus. There's a phage against Bifidobacterium infantis, and so on and so forth. But guess what? When you are healthy, those phage are healthy, the microbiota is healthy, they're just keeping each other trimmed. Does that make sense? I mean, you've seen a nice, beautiful manicured lawn where you have plants where they're supposed to. You've got the trees in the background, and then you got the shorter bushes, and then you got the flowers, and then the lawn in this beautiful symmetry. That's what phages do to your microbiota. When one organism gets out of control, the phage is there to bring it back down to a healthy level, and it's a balance. We all believe in balances, do we not? Homeostasis and balance. How many of our ancient healing methods are all about balance, yin and yang? These guys are there for balance. The hypothesis is you kill these guys first, you've just set off the imbalancing pendulum from there on out. Okay? All right. They're located through the gut mucosa. They're now being called the third immune system. You know how we had the third gut? I think Sarika was kind enough to present you the third brain. Sorry, not third gut. Third brain. We're not cows. The third brain is the microbiota, right? Well, now we have these guys who, it's the tertiary immune system. We keep them around when we can, when we're healthy, to actually help fight pathogen invasion. So, and there are a lot of other animal examples. The skin of fish, right? The scales of fish. Have you guys seen the mucosa, the fish? They contain things like phage in that to protect them from constant bacterial infection when they're in water all the time. So we got a lot of examples. Pretty amazing. We can take advantage of it. Now there's a lot of variations. They vary based on race, diet, culture, health status, genetics, environment. They're just like your microbiota, which means we have a unique signature, both an unhealthy one and a healthy one. Mutual organisms, I'm not going to go over this, but these are definitions that you guys just need to learn, just like the omics. You need to learn these. There's our phage, dissected. It kind of looks like a lunar lander. Kind of cool, huh? This is what it does. It injects it into the bacteria, and then it replicates, bursts the cell, and comes out and does it again. What happens when it trims the herd down to a lower level? It stops doing it. You've reached balance. Right? And in the cases of the phage that we offer you, they'll just leave. They'll go on to the next place. They'll go into the sewer system, the mice will get them, or the rat, and they'll do their job there, and they'll just keep going through nature like that. That's what they do. So prebiotics benefit us in that way. So my analogy for phage and prebiotics, again, twofold. One, regulatory. Two, because we don't want to deal with the hospitalizations, do we? But what we do want to deal with is a healthy microbiota by getting rid of these low-level issues that we see, causing dysbiosis and causing all the other subsequent phenomena like inflammation. That's why we're looking at these phage in general. So prebiotic, here's the definition of a prebiotic. You guys have already told me that definition. We normally think of it as dietary fiber. Did you know you guys produce your own mucosa or prebiotic? That's a prebiotic. The reason you produce all that mucosa in your lungs and in your GI and throughout the urogenital, that's to feed and harbor the phage and the good bacteria. The glucosaminoglycans you guys make for that reason. And then we can add into that a lot of these other things. So it's really no longer about what we need to live. We're trying to deal with getting us back to where we want to be, and the phageome is one of our tools. And then we have, of course, going all the way back to Doc, we have the Herbalomics. And then, of course, we have other things like carbohydrates and probiotics and so on. Looking at this piece now I'm giving you some research that supports everything we've talked about up to this point. Jeremy Barr is a university researcher, and he's discovered certain areas of phage, and he's been part of the phage research, where he's showing that they do have an important role, and they prevent invasion, they prevent this low-level infection. And I think he's the one that first termed this secondary immune system. If it's not here, it's in another publication. But you can see it's a growing field. It's new, but it's going to grow very, very rapidly. You guys need to be on the cutting edge, which is why you're here today. This is a cutting-edge piece of science you're getting right now. They have active roles in shaping the ecology of oral bacterial communities. I didn't get a chance to talk to Kuratola before he left, but you remember how he said prebiotics are going to be the future of oral health? Can you see how this would apply to that concept? We can't get the probiotics to stick to teeth the way we want them. Imagine a mouthwash of a phage that kills gingivitis. How cool would that be, right? So that's in our future. That is in our future. So the dysbiosis, I've kind of beat this up quite a bit, but this is some of the issues that we face. Why are we having such a problem with phage and dysbiosis? Well, clearly, diet is an issue, right? It certainly has changed, and there's a lot of statistics, and I didn't want to bore you guys even more than I'm already boring you, but when we look at the Western diet and we look at phage now and salmonella, when our diet goes down, these low-level infections rise. People that have a much healthier diet don't seem to have these low-level, these basal infections or dysbiosis. And I think you've experienced that in your own clinics, right? And I'm picking on salmonella specifically because of the phage that we're going to be talking about today.